All right, so homework 3 is released. We're starting the homework 3 content. We just finished the 2 weeks of homework 2, so you should be wrapping that up. Obviously, the deadline is this Friday, but you should be wrapping up homework 2. As with homework 1, I recommend that you finish that as early as you can because we're getting into homework 3 content. So if you're still doing homework 2 all this week, and you're not starting homework 3 content until a week after we've been talking about it, you're going to start slipping behind. It's tough to, it can get tougher to get caught up. So let's take a look at homework 3 real quick. Just dip in here. I'm not going to go over everything with this, but I at least want to give a nice overview of what we're going to be doing. Why rewrite? So you can use the homework 1 and 2 stuff. The homeworks are designed to be in sequence, that you're building one big project, one big server throughout all 5 homeworks, and you're adding features to it as we go along. That said, you might want to rewrite a good chunk of your homework 1 and homework 2 code if you didn't design that very well. As you add more features, if you, for example, hard-coded all of your everything in homework 2, you can get away with hard-coding just about everything with homework 2. You're going to have to go back and fix that because you just push that work off until later down the road. So as you progress, you're going to have to rewrite some stuff if you didn't have good design practices, but you should definitely reuse that code as much as you can. And if you really put a lot of effort into homework 1 and 2 and designed it really well, that's going to pay off for homeworks 3 and onward. And likewise, if you really do a good job on homework 3 with good design and good encapsulation and, either OOP or FP or whatever you want to use, or that's going to pay off down the road because you're going to reuse all this code and you're going to reuse it in more complex ways. Yeah, it didn't ask you. But rewriting all of homework 1 and homework 2. If you already did that, it's good. You're getting good. Did a lot of cleanup in homework 2 from homework 1. Yeah, exactly. So y'all are already feeling this a bit. So we're going to expand that homework 1, homework 2 functionality. In homeworks 1 and homework 2, we built what I like to call poster sites. All we did was just post information out there. It's like printing up a poster and then pinning it somewhere on a bulletin board or something. People can look at it and consume your information. It's a very one-way street. You're sending information to the users. We dabbled just a little bit into some form of interactivity by allowing query strings, but not really. Homework 3 is where that's going to change. This is where, and I'll say this again when we get to the slides, but this is where the course, in a kind of real sense, really begins, is with homework 3. Because this is where we're getting dynamic content, where our users can interact with our server, and where our users can interact with each other, which is where our websites start to become web applications, the namesake of the course. So this is where we're actually building our first web application, where the users can interact through the server. With the users not interacting through the server, we're just building websites or web pages, whatever you want to call them. I call them poster sites, where we're just slapping some information up on the internet for users to download and consume. Nothing wrong with that. I mean, that could be an entire game and just be browser based, but we want users to interact with each other and with our server. So that's where we're going to start today, is that interaction, that dynamic site instead of a static site. And there is a huge increase in difficulty in... Should I say this? I think, in my opinion, this will probably feel like the most difficult assignment of the semester. Not saying that homeworks 4 and 5 are easier. I think those are more difficult assignments. But this is the first one that's really going to force you to understand everything we've been talking about so far. So everything is going to come back. You're going to have to really understand encodings, the format of and structure of an HTTP request. Everything that we've talked about so far, you have to have down really solidly, plus all the new stuff that we're going to learn. So the difficulty is going to feel extreme for this one. Unless you've been keeping up with everything, then it won't be too bad. And then homework 4 will be more difficult, in my opinion, but you'll have so much more understanding of what's going on at that point. that I don't think it'll feel like a harder assignment. But just keep in mind, homeworks 1 and homeworks 2 are kind of jokes compared to this one. I don't say that to scare you. I don't say that for any reason except to make sure that you're managing your time accordingly. If for homework 2 you get away with starting this Thursday and you still get it done by Friday, good for you, congratulations and all that. You're not going to do the same thing on homework 3. You're not going to be able to cut it close like that the same way you did with the first 2. So just be aware, be forewarned. There's a lot there's just a lot in here. And there's some kind of hidden difficulty if you're not paying attention to the lectures very well, specifically when it comes to buffers. Anyway, let's get into what we're doing. For this, we're going to build 2 forms, and each form kind of comprises 2 of the objectives. So there's 2 real big objectives in my eyes anyway, and each one is broken down into 2 objectives. Each one is a form. So the first one, you're going to build a form that takes at least 2 inputs. I have a sample form here. If you just want to use this and add this to your site, that's fine. But if you built your own site, especially if you did the bonus for homework 2, feel free to make this form whatever you want, as long as it takes at least 2 inputs, and at least one of the inputs is a text input. Then everything else is up to you. So this is open-ended, but I give you a default option. If you just want to focus on the content of the assignment, just take this form, cut and paste it into your submission, and get on with the homework. But if you're building a site that you really want to build something through these homework projects, this homework project, make the form your own. Just make sure you fit the requirements. At least 2 inputs and at least one of them text. The user is going to send information in the sample form, their name and a comment. So a basic commenting system, just like what you're seeing right now in Twitch chat or YouTube, the comments below the video if you're watching on YouTube, where you have a username and then their comment. That's the functionality we would have with this form, with the sample form. Post your comment. Yes, our users can choose whatever name they want. We'll fix that when we get to authentication. But for now, they get to input any name and any comment that they want. Your server has to accept submissions from this form, remember those submissions, and serve those submissions in Objective 2. So in Objective 1, you have to respond with the content, but if you do Objective 2, you don't have to do anything with that. Objective 2 is updating your homepage to have all of those username and comments displayed in some way, any way of your choosing. So you have to take form submissions, remember those submissions on your server, and you can store them for our purposes on this assignment. We haven't talked about databases yet, so if you just want to store those in a data structure and have them not even persist over a server restart, that's fine. If you want to use file IO, all the better. But you can just use a data structure to store that. So store all that information and then add it in an HTML template. You see what I mean by everything's going to come back at you. Have an HTML template for your homepage that's going to display all of that information for every form submission for that run of the server at least. The next one, very similar, except we're taking image uploads. So we're building an image sharing site for this, again, sample form, same thing. If you make your own, there has to be at least 2 inputs, and one of them has to be in a file upload of type file. So at least an image upload and at least one other input of your choosing. It doesn't have to be text this time. It can be whatever you want it to be. I did image with a caption, so users can share images with captions on them. So we have effectively a chat app through Objectives 1 and 2, and an image sharing app in Objective 3, share images with your posts. Your site has to save every image that's been uploaded, save it as a file on your server. So technically, you could get away with data structures here again. Remember the caption associated with that file, and then add to your template of your homepage a way to display all of the images along with their captions that have been uploaded through this form. So we're building a full image. That was Objective 4, was hosting them all on your homepage. So we're building a full image sharing site where users can upload their images and every other user can see all of those images, share them with each other, and the commenting system at the top to be able to make comments. Everything short of, I almost did this, but there's enough here already, is being able to comment on each image independently it's just a little too far. I didn't want to. I got to manage the difficulty here a little bit. Yeah, so basically a social media app. It's basically, if you've heard of this this website called 4chan.org, it's basically 4chan at this point, except we can't comment on the images, and we can't respond to an image with another image post. That's basically what we have here. And then the bonus objective is to add cross-site request forgery tokens to your forms, where you're not allowing cross-site requests. So if somebody on a different site, some making some other server and they are hosting their own web content, if they want to, goodness, is it 15 minutes in already? If they want to host content, they can't write JavaScript that makes requests to our form, or they can't add a form to their page that submits to our server. That's what a cross-site request forgery token gets us, is we don't allow submissions, we don't allow HTTP requests that didn't come from a user who legitimately visited our page. It's an important security aspect. We'll have a whole lecture on this talking about this. It's a little much for the assignment itself, so that became the bonus objective. And same stuff for this, except we do have security concerns for every of each of the 4 objectives. Any security risks, security vulnerability, it's a 0. This I think I've talked about it a little bit this semester already. I've talked about it a bit before in other semesters. Contemplating what a security risk, what the penalty for a security risk should be. I would go all the way up to, I've considered at least, going all the way up to an F in the course. If you have a security risk, like that's the most important thing when you're building web apps. And now that we're building dynamic apps, where you're holding and hosting user-submitted content, we're really opening up the possibility to have a lot of vulnerabilities and a lot of open doors for attackers. So we have to be security conscious, especially starting with this assignment. So we're going to be talking about that a lot throughout these next 2 weeks and really throughout the rest of the semester. So that's homework 3, very quick overview. Same scoring as before. And let me know if you have any questions about that. Jory, why so sad? So this is the thing though. This is what I kind of like. It is a difficult assignment. I don't want to scare you off, but I don't want to sugarcoat it either, because if you get into this assignment and I treat it just like it's homework 2, you're going to get partway through objective 1 and say, Jesse, what the hell are you doing to me? This is insane. So I do want to warn you about the difficulty increases. This is not a homework 1 or homework 2. But on the other hand, when you're done with this homework, you have a full image hosting, sharing website. It's pretty freaking cool. Once you finish this one, you should be feeling pretty damn good about this. And we do have, this week doesn't really count for anything. So if you do, you don't have to use this week to spend any time, but you do have extra time. This was strategically placed in the schedule where you do have that extra week to calm down, come back in week 8, and still have time to work on homework 3. So just a reminder of that too. Just like Matlock in 312, yeah, you could think of it like that. It's in it, and it is one of those homeworks where we are really nailing down a lot of the fundamentals and a lot of the core of what this course is. Once you finish this homework, you really have a good understanding of what we're doing here and what web servers do in general. You'll have a good grasp on, effectively what the internet is and how it works and how web apps work after homework 3. There's a lot of juicy stuff in there. So with that, let's get into some of that juicy content. Kobe. I don't think he's going to come. But maybe after lecture. He's behind me chewing on a bone, I think. Homework 3 is going on the portfolio. Well, your whole the whole homework project should go on your portfolio. You shouldn't be like, I built this image hosting, uploading, sharing, image sharing site. Don't put that on your resume. Put the whole damn thing. All homeworks 1 through 5. I built this image hosting site with live interactions through WebSockets. I think the interactions will be chat. We'll have basically like Twitch, we'll have chat on the sidebar with authentication, with secure password storage. That's what you want to put on your resume, the whole damn thing. There's no reason not to. Plus your project. You should have 2 projects on your resume after this class. Unless you have better projects that squeeze them out so you can keep it to a page. You should have 2 good projects on your resume. If anybody leaves this class without at least 2 projects on their resume, you're doing resumes wrong. You should have 2 really good projects. Built this web server from scratch with image hosting and all these crazy features, authentication. And also this other project that has way cooler features because I was able to use frameworks. And I built both of them, plus teamwork experience. There's so much good stuff in here to put on your resume. Plus all the one really nice thing about when it comes to resumes, at least with web technologies, I think this is really annoying when you're learning web technologies, but everything has its own acronym, it seems like. Next week, we'll learn AJAX, which is just making asynchronous HTTP requests. It's nothing new. It's nothing fancy or anything, but it gets its own acronym. It's so ridiculous that it gets its own acronym. But that looks great on a resume. On your resume, you already have HTML, CSS, JavaScript. You'll have AJAX, HTTP, UTF-8. If we don't put UTF-8 on there, I mean, a developer is just going to laugh at that, but HR is going to be impressed. One nice thing about web technologies, the way the ecosystem looks great on a resume. Okay, so let's rip through some slides here. Let's talk about this. So we're starting to make dynamic pages now. So far, we've posted static content. That's cool. We just threw some information up on the server. We let users manipulate that content a little bit through query strings, but not really. Like, they could choose which images that they were shown, but it was from a list of fixed images that we had already on the server. They could choose their name, sure, but they can't really interact too much. We could build a dynamic site with query strings alone, but my goodness, that would be painful. So we're not going to do that. So aside from query strings, we had completely static content. Nothing changes. Now we want to move into dynamic content, where the users can send us information. We're going to host that information and have that alter the state of the server and have the server serve different content after that. And this allows users to interact with each other. So the basic app and the app I'll use for lecture examples is a chat app. A chat app is one of the most basic things. The users are sharing text with each other, and the server is acting like a liaison to be able to allow users to communicate with each other. That's the beginning of building web applications. We're no longer building websites. We're not making web pages. We're making web applications that can be this whole piece of software that users interact with and use instead of just going to a website to gain information. Who are you responding to? So to do that, we're going to start with HTML forms. This is going to give users a way to interact with our sites. There are other ways we'll see later in the semester. I guess not too much, but you can basically use JavaScript to make your own forms and your own ways for users to interact. But we're going to start with HTML forms, which will give users a way to send information to our server. So let's break these down. Not too much complexity in the HTML itself, but I do want to go through it for a few slides. And at the top level, we have input elements inside a form element. So we have these inputs inside a form, and that's going to build our HTML form. This is going to render on the page the way we'd expect with text boxes that the users can type into and a button. So let's break this down a little bit. And see what's going on with this form and then how it works. So this form, when submitted, is going to make an HTTP request, and then whatever our server responds with, that's going to be rendered to the page, and this will trigger a page load. When you submit a form, there will be a page load. Later on in the semester, there won't be, but for now, there's going to be a page load. You'll notice most forms you use on the internet these days don't really trigger page load. depending on which site you're going to and what you're doing. But like a social media site, submit a comment or chat right now that you're typing in isn't going to trigger a page load. Even if you're typing a comment in YouTube, it's not going to trigger a page load. But for now, our basic HTML forms do trigger a page load. So let's break this down. First, the form element is going to take a few attributes to specify what this form does. So for this, we're going to specify the action and the method. The action is going to be the path for the request that's going to be made when this form is submitted. So when a form is submitted, it's going to send an HTTP request to our server. The action specifies the path. So this is going to make an HTTP request and the method is going to specify the type of request. The method is going to be GET. So submitting this form is going to submit a GET request to the path form-path. So your server on your server side, you're going to look for method equals GET, path equals form path, and then handle this as a form submission with the data that the user entered. You're going to get that data, you'll be able to parse it, and do whatever you need to do with that data. The form consists of multiple, or I guess could be just one, but inputs. And this is where the user is going to input information. So here, the type is going to specify how this is going to be displayed on the page. I have type equals text. That means I'm going to get a text box. Those boxes where you click on them, you type in, you've seen them all the time. That's going to be a type HTML input of type text. So we do type text to say this is going to be a text box. We give it a name, and this is going to be the name of the value that we see on the server side. So we're going to get these as key value pairs or name value pairs, where the key is the name of the input, and the value is whatever the user inputted into this input, whatever they typed into this text box in this case. So we have a text box named commenter, and then I gave it an ID just so I can reference it over in this label. So it's a very good idea. You really should do this all the time to provide, it's a good idea to provide labels with all of your inputs. So this does a couple of things. First we're going to do this by setting the for attribute with the ID of the input that this is for, so the browser knows to link this label with this input. This does a couple of things. One, it's great for screen readers. This input doesn't really tell a screen reader, so somebody who's blind using your site, using a screen reader to figure out what the content is, this doesn't tell them anything about what's going on. This does, and usually you just look visually and it says enter my name right next to this text field. I got what's going on. With a screen reader, and you can't see the way things line up on the page, that might not always be helpful. Add a label. The screen reader is going to read this and tell them that it's associated with this input. So it really helps for accessibility reasons. This also is associated with that input in the sense that when you click on that label, it's going to focus this input. This is something that's kind of a pet peeve for me now that I know how this should work, and when it doesn't, it's messed up. Especially with radio buttons, when you have those circular, we call them radio buttons, those circular buttons on a page, and you have multiple things you can select. And when you have a page where you click on the text next to the button and it selects that option, that means that they have a label that's linked for that input, for that radio button. If you click that and it doesn't work, and you actually have to click on the circle itself, that means they don't have a label set up with it. They don't have good accessibility, and they didn't give you this click the label to focus the input. So a little pet peeve of mine, whenever you see that, you know that that site did not do this. I forget what it is, but actually I know what it is. Approving timesheets for TAs. There's a form, I gotta click it, constantly every 2 weeks, a whole bunch of times, like 20 times, and they don't have the label. So I always try to click on the text to select the thing that I got to select 20 freaking times. Never does, and I never learn my lesson. I got to click the thing every time. Anyway, so we use the ID. The for has to match the ID to know what that label is for. And then an input of type submit. This is going to create a button that when clicked is going to submit the form and send an HTTP request with the information that the user entered. This takes a value attribute that's going to be the text that's displayed on the button. And we built our first HTML form. Now we used method get and action form path. So when the user fills out this, say they fill it out with Jesse and good morning on the form. Oh, I should have gave it a picture of the form. We'll see it later, but I should have put a picture of the form on the slides. When a user submits that, this is the request that you're going to get. Since we specified get as the request type, you're going to get an HTTP get request for the path /form path with a query string containing the key value pairs that the user entered. So commenter, if I enter Jesse, commenter equals Jesse, and comment, and these are whatever we name them. I just happen to name them commenter and comment. And comment equals whatever I typed in this text box, which was get good morning with an exclamation point. This is the same URL encoding that we have for query strings. So, and I did look into this. I guess plus is a common replacement for spaces. Plus is commonly used for that. And there's all kinds. It was a kind of a rabbit hole. There's a lot of information about pluses or %20. But plus is common for replacing spaces. Then my exclamation point at the end got % encoded as %21. Morning, Muffin Man. So if we have method of get, the request is going to be as all the information of the form as a query string. Now, that's not really what we want. I mean, we've done that before. We could have done that in homework 2. I could have had you make your query strings with a form. But this has strong limitations. That's why it's not what we want. So the query string has some limitations. A few that we didn't talk about. So one that we did talk about, the URL has to be ASCII only. So anything that's non-ASCII has to be % encoded. So what if we want to upload a file, which of course we want to do for this homework. If we want to upload a file, we have to encode it as ASCII, which we can't do because it can't be ASCII encoded. It's bytes that represent PNGs or JPGs or whatever. So we'd have to % encode the entire file to represent the bytes that we're sending, and then decode that on the server side. Not ridiculous, but not painless, not completely painless either. Another issue, a bigger issue, is that browsers and servers have limits on the length of a URL. So if we put that whole query string of a whole file in the URL, the browsers and servers are going to start kicking that back and saying, no, that's not allowed. Browsers and servers also have limits on the entire length of the an HTTP, of the headers of an HTTP request. So the request line and all the headers, everything up until that first blank line. My internet cut a little bit there. Hopefully that wasn't too disruptive. Everything up until that first blank line that separates the headers from the body, there's a limit on that. And servers usually have a limit of 4 to 16 kilobytes. I think some servers go up to 32. But there's a limit on the size. If you go over this limit, some servers like Nginx or Apache, they're going to say your request headers were too large. We're not processing this, and just respond with a 400 level error code. Like a 417, I want to say. Something like that. It's going to say requests too large and just kick it back. So unless we want to limit ourselves to 4K file size, we got to find a better option. So enter post requests. I've alluded to this before. I'm sure you've heard of them before this class even. But let's use some post requests. Post to the rescue. So a post request is used when a user is sending information to our server as opposed to getting information from our server. So far, everything's just been the user retrieving information from our server. Now the user wants to send information to the server, and we're quickly going to outgrow the query string. So let's switch to post before we outgrow that query string. And the post is going to send a request that includes a body. And this is going to work in the same way as our responses. So we're both using HTTP. The format of an HTTP message is the same whether it's a request or a response. The only difference is the very first line. A request is going to have that request line specifying the path and the request type. And a response is going to have a status line which specifies the status code and the human readable explanation of that code. Everything else, all the headers and the body, everything else is formatted exactly the same. They're just HTTP messages, I think is the term, whether they're get requests or responses. So you can expect HTTP requests that follow the same format as your HTTP responses, specifically meaning that we're going to have content length and content type headers. So you're going to have to start parsing these headers, something we haven't had to do yet, but hopefully you've at least been thinking about. You have to parse those headers that you receive in the request, read those headers, and then use the information in those headers to read the body of the request. And specifically, content length is going to be the most important one. Content type, we're not going to stress too much about, because based on the request type and path, that combination, for the homework server, just to cut one thing out of our focus, one last thing you have to worry about is you can assume that the content type is going to match what you expect it to be based on the request type and path. So if they're making a form submission, a post request to file upload, for example, you can assume that the content that you're going to look at is going to be a file with an image, with a caption. You can assume that content type is going to be the same. Content length, you do have to read. So you will have to read the content length header. And this is one of those things I recommend writing general code that parses all of the headers and puts them in a key value store data structure in your language of choice. Puts all that information in a key value pair data structure. And then you can read the headers one at a time, because we will be reading a lot of headers moving forward. We will have to read more than just content length. So if you hard code this to say, if line starts with content-length, then parse it specifically for content length, you're just pushing work down the road. So that's one of them things that I highly recommend, writing a general header parser right now, right for this homework. So we do have to read that. So a post request to find to parse these things and to find the content that we're interested in, look for that blank line. That's the end of the headers and the start of the body. Read the content length header. Content length is going to tell you how many bytes are in the body. So that's going to tell you how many bytes after this you have to read, and then read that many bytes. So if content length is 100, look for this /r/n/r/n. Once you see this, right from here onward, read 100 bytes of information, and that's your content. You do have to read this content length. This is going to be extremely important when we get to file uploads for various reasons. So when you're doing Objective 1, you can get away without reading content length. Don't do that, because you're just pushing that work down the road. You're just pushing it down to not even the next assignment, but later on in this assignment. And when you get to image uploads, I know exactly the error that you're going to come to office hours with. If you're not reading content length, you're going to say the request only contained the headers and no body. What's going on? And I'm going to say you didn't read content length and wait for the rest of your information to come in because it was buffered. So you do have to read this content length. I guess I can read this one. And this is the same thing your browsers do when you send a response. They're going to read content length, content type, and that's going to tell them how to parse your response, whether it's CSS or JavaScript or HTML or plain text or a redirect. Content length, content type, that's going to give them the browser hints as to and other headers, your location header for 301. It's going to tell the browser how to render your information. You're now on the other side of that where you're getting requests with bodies and you have to parse that information to get what you want. So let's use a post request. Let's change our form. We just have to change a few characters here and change the method to a post request. Now when the user submits the form, very small change in our HTML here, but now when a user submits a form, we're going to get a post request to the path form path. The format of that is going to look like this, where the content type is going to be, actually you do, now that I think about it, you do have to read content type for the next thing, starting Friday. The content type is going to be application/x www form URL encoded. I'll say URL encoded for short whenever we have this, because I don't want to say the whole MIME type, but this is just another MIME type. URL encoded, meaning that this has the same encoding as the query strings that end up in your URL. We're going to use the same encoding procedure. So the only thing that changed when we changed to a post request is that we put the query string content in the body of the request, and we get a content length which tells us how many bytes of information there are in there. So we do get around the limitations of the size of the headers and the size of a URL. So those browsers and servers that said, hey, you can only have up to 8K bytes in your headers, we got around that. We said, okay, that's fine. We're just going to add a content length and put that information in the body of the request instead of the headers. Instead of putting it in this information, we're going to put it after this blank line, put it in the body. We're good. Everything's good with that. So we do get around that, but we still have this kind of gross format of the URL encoding. Specifically, we can only use ASCII here still. That's not really what we want. It's not really what we want because ASCII can get, it's just limiting. If, like I said earlier, if we want to send a file or we want to send an image, we're going to have to percent encode every byte of that thing, unless they just happen to be ASCII bytes. Yeah, you read the number of bytes. So here you would look for this new line character, this empty line. Everything before that, you're going to parse as headers. And when you're parsing this, you can assume that all of the headers, this is part of the protocol, you can assume that all of the header information is ASCII text. That's why, part of why the URL encoding has to escape all the non-ASCII characters, because everything in the header, we assume it's ASCII, because what else are we going to do? We have to assume something. We have to start somewhere. So every browser, every server, everything we write, we're just going to assume that this is ASCII only, and everyone on the internet is only going to send ASCII text in the headers. So we look for the new line, we parse all this as ASCII, we look for the content length, read this, and then we read that many bytes of the body after this new line, and then we can look at the content type. Here we just have URL encoded, so there's nothing more to add because URL encoded has to be ASCII. But when this is not URL encoded, then this can specify the encoding and it can say, hey, this is UTF-8, and then we can start parsing this as UTF-8, and we can get some better content and better information out of the body here. So this gives us some advantages making a post request, but we're still URL encoding, so like what the hell, we didn't really gain anything. We just got around the size limits of the headers. And we will, this is a foreshadow, but we will upload images during testing that are going to be larger than your buffer size. And you're going to have to really pay attention to this content length. And you might have to read from your TCP socket multiple times to get all of the bytes, which Danaski points out. You have to read in increments because when you read once, you might not get all the information for that request because everything's being buffered. So you have to be aware of buffering. That'll be next Monday's lecture. Don't sweat about it yet. Right now we just want to know what forms are and how they work. So let's change this encoding type to get away from URL encoding. We can do that by adding another attribute to the form, which specifies the encoding type. There are only 3 choices for encoding type. One, we already saw, the default one of URL encoding. The one we're about to see now, multi-part form data, which is the best one that we're going to use extensively. We're not even going to bother with the other 2 unless you want to create extra work for yourself for objective 1. I do allow it, but you should really just use multi-part form data. This one, which is the best one, which we're going to use for everything, which is great. And text/plain, which you should never use ever. Just don't use it. Text.plain is inconsistent. There's no specific spec of how to encode things in plain text. It's just one you shouldn't use. Maybe for debugging purposes, but never on a live server. So when we use multi-part form data as our encoding, now we get a completely different encoding. And this is the one that you'll want to spend a while on your homework, or rather you'll have to really parse this. This is one of those things where I'm going to show you the format, and then it's up to you to parse this format and get the information that you want. This format gets a bit more complex than URL encoding, but for good reason, because it's very flexible. You can send all kinds of information using this, and you can even mix types. So before, our content type just had some type and maybe an encoding. With multi-part form data, we're going to break up the body into multiple sections, each which has its own header and body separated by a new line. So effectively the same format as an HTTP request itself, except without the request line. And then we can specify what type of information is in that part of the form using extra headers. And here we only have one header for each piece of information, but there can be multiple headers here. So when one of these is an image, you're going to have a content type specified in the headers to specify that, hey, this is an image. Maybe don't decode this as UTF-8, but then the text, like the caption of the image, is going to say, yeah, this you should decode as UTF-8. So we're going to have mixed content and content of different types and a lot more parsing. So in your content type, you do have to read this, and we do have this, again, some more parsing. This is, hopefully I warned you enough, but this, at least the first parts of this class, a lot of string manipulation. We have a value separated by a semicolon, which is going to give more values, more associated with this header. So here we have a semicolon, and you're going to get a boundary, which equals some string that's going to specify the separation between values down here. This string will be specifically formulated to not be contained in the data at all, because if this substring were part of the data, well, now all our parsing breaks. So we have a random looking string, which is going to act as a separator to be able to separate the pieces of content being sent. For some reason, it leads with 2 extra dashes in the body. Don't ask me why. I should look that up someday. But anyway, it's just 2 extra dashes for these boundaries. I think I think it is because it's signifying the end of the previous boundary. I don't know. But we're going to have these 2 leading dashes. We'll separate our content based on those separators, based on that boundary. And then for each one, look for the new line, parse the headers. Specifically here, we're going to get the name, which is following the same format as above. You can start seeing what I mean by write a general header parser and use that code, reuse that code whenever you need it. So on this line, call your general header parser that has a key, puts this in a key value data structure where this is the key and this is the value, and ideally separating this into its parts as well. General parser there is going to go a long way. It's going to help you a lot throughout this semester. So separating the key and the value and separating the different parts of the header. It's going to help you. So you look for the boundaries, you read the headers of each one, looking for this new line, and then after that, read the information here. We don't need an extra content length here because we already have the total length of the entire body. We're going to read the entire body and then start parsing based on this boundary. Once we see the dash dash and boundary again, we know we've reached the end of that piece of information and on to the next one. And for our form here, it's going to separate each input. So I inputted the commenter text field. It's going to put it here as one boundary, and the comment is going to be another boundary with the information. And now we get UTF-8. I don't have percent encoding here, no plus sign here. We get some good information. The last boundary is going to be followed by a dash dash. So don't try to parse this. Don't try to parse headers and everything on that last boundary that's just a dash dash. Just a heads up on that. That'll break your parsing code pretty quick. And just a few extra things. So this parsing the multi-part form, this is a big part of homework 3, by the way, in case that wasn't clear already. That's a big portion of homework 3. But quickly, if you want to use some custom forms, especially if you're creating your own site, if you did the bonus for homework 2 and you want to expand on that, there are other inputs that you can use. Here's one for radio buttons, just showing the format quick. For radio buttons, the input type is radio. And then for each radio button in a group, you give them all the same name. This is going to allow your user to select at most one of these options. So you can only select either 1, 2, or 3 in this case. And then the value is what's going to be sent. So for example, a user selects 2 as the button and then submits. On the server, you're going to get an input with name choose 1 and value 2 because that's what was inputted. If they choose 3, you're going to get name choose 1, value 3. So that's a way you can let your user select with radio buttons. Similarly, we can have drop-down menus. Drop-down a little bit different. We have the select HTML element with options contained in it. And this is going to list all of these options in this order in the drop-down menu. The name, this is what you're going to get on the server. You'll get a name with either first, second, third, or home. And keep in mind that the labels here, this is just the text for display to the user. What you're going to get on the server side is always the value attribute. And then when they submit, you'll get whatever they selected. And as always, there's tons more. Head over to W3 Schools. You can look at all the different form elements that you can add to a form. So all kinds of stuff. I'm not going to just go through each of them in the slides because you're fully capable of going there and finding out the ones on your own. Plus, it's optional for this course, so I'm not going to spend too much time talking about it. And we actually ran out of time for demos. Time went by quick. I didn't realize how much time I spent talking about the homework, but I can go over demos in this bonus time, but I do got to cut a lecture right there. Maybe I'll go over demos on Wednesday. I think I'll have... Actually, Wednesday is mostly a demo day anyway, so I can just add the demos I was going to show today to that lecture. But those of you who are going to stick around, I can show them here right now as well, and then go over them again on Wednesday so it's in lecture proper.